Hello, my name's Shaun Harrigan. I'm from the European Centre for Medium Range Weather Forecasts. I'm the technical officer on the C3S project, Multi-Model Seasonal Hydrological Prediction Service. And today I'm going to give you a talk on the road to operationalisation of that service. Sorry I can't be there with you all today. Unfortunately, I picked up COVID before travelling last week, but I hope you're all having a good General Assembly so far. So the operational Seasonal Hydrological Prediction Service, in a nutshell, this service is at both pan-European and global scale. It aims to provide probabilistic multi-model hydrological seasonal forecasts, as well as a set of reforecasts or hindcasts that allows users to be able to, in near real time, understand what the current forecast and hydrological variables will be, but also allows many users and different downstream applications to understand the skill of the underlying data itself and explore where sources of skill might be through provision of long-term set of hindcasts as well. One aspect of this service as we're going forward is integration of the Copernicus Emergency Management Service hydrological seasonal forecasting components. I'll mention those in the next slide as well. And really, overall, what we're trying to do is build a harmonized operational interface for users in the water sector that need global and European data at seasonal timescales. And this brings around standardizing some definition of indices and tailoring different products for different end users, looking at multi-model compositions of the different data sets, as well as bias adjustment procedures, as well as looking at skill and uncertainty calculation and visualizations. Another key component is also providing a common climate data source structure, so users who are interested in either the global or European data have a similar structure and can use the models and data that they want from either one. So just a timeline on this this contract and this service. It started off with some pre-operational contracts through C3S. The first was on creating an operational sectorial information system for the water sector. And that started with the European scale and led by the Swedish Meteorological Hydrological Institute. And then a second contract then bringing into the global scale provisions for the environmental forecasting applications contract was led by UFZ, the Helmut Center for Environmental Research, and that followed very similar onto what the European scale was doing for seasonal forecasting, but at a global scale with global scale models. At ECNWF, we're also the computational center for the Copernicus Emergency Management Service, the flood service. And within the flood service, we run two hydrological models, one at the European scale, which is the European Flood Awareness System, and one at the global scale, which is the Global Flood Awareness System. And both these models, there is a seasonal hydrological forecasting component. And so also with the two previous contracts that we're looking at, a multi-model service for Europe, global, and now with the CHEMS floods data, this current contract is bringing all three of these components together in a consistent operational phase that has started in May 2022 of this year and will continue to April 2024. And this is in two lots. So one is a global scale and a European scale. I'm glad to say that both contractors from the previous phases have been successful in that. So both UFZ and SMHI, as well as my role as technical officer and also a member of the team at ECNWF working on the Copernicus Emergency Management Hydrological Seasonal data. We're really trying to bring all these three components together into one coherent system for the benefit of the users. So first, if we look at the global service and just a kind of an overview of the different components. So first of all, the service is at around a 10-kilometer resolution globally. It starts with initial conditions. So these are driven by Year 5 land to get the initial conditions of the climate state fed into the hydrological models. We then have forecast data from currently CES5, so the ECNWF seasonal model, version 5, as well as the corresponding set of reforecasts. These are downscaled and bias corrected using a quantile mapping technique before being fed into 4 hydrological models that vary in different complexities. From each of the models, they have a common set of output variables ranging from bias corrected temperature and precipitation right through to more hydrological variables like runoff, soil water, and snow water equivalent. There's a common routing scheme that then takes the runoff and routes that into river discharge, completing the set of variables. From the output, there's quality control checks, etc., to make sure everything looks okay, and that the skill of the system is also reported for the benefit of users. And then all that raw data is then uploaded to the climate data store available for downstream application. I hope you've already had a chance to see Stefan Tober's poster where he goes into more detail on this. I believe the poster hopefully is still available, if not. So looking at the European service, a similar protocol in terms of the steps involved, but slightly different data sets, given the smaller scale and the different data available. So the initial conditions climate data available, instead of using the Reanalysis, we have access through the EFAS meteorological forcing, which is at a 5 kilometer resolution. So this is much higher resolution and is an interpolated product based on observed precipitation and temperature gauges across Europe. And that's used for the seasonal service, European service. It's the same forecast and reforecast data currently from CES5, and these go through a similar procedure of downscaling and bias correction, as well as producing a set of reforecasts and real-time forecasts. In the European service, there's 3 hydrological models. One is a catchment scale E-height model, as well as a gridded scale E-height model. Also, the gridded scale models are at 5 kilometer, as well as the Vic-Were model, also at 5 kilometer. The current variable that is output from the service is river discharge, but as part of a harmonization approach and component within the current ongoing operational contract, we do plan to also standardize as much as possible the variables across the Europe and global service to include runoff, snow, soil, as well as some of the bias corrected and downscaled climate data as well. So the output variables are also quality controlled with the skill assessment and also uploaded to the climate data store. And just an example of the climate data store entry for the European service, we have the seasonal forecast to the left and the seasonal reforecast to the right, and both those can be either searched on the CDS page or using the QR code here if anybody has time. Just briefly look at the CDS structure. So in the pre-operational phase of the project, we have in the European one, we have, for example, we can select river discharge with a number of reference variables below or above the upper and lower tercile. We can also select skill scores based on Brier or continuous rank probability skill score for different months. We can select a combination of hydrological models as well as different months. And so this will also be available through the CDS API as well. And from that data set, it allows the possibility of opening up to build some apps. And one of the apps currently available and it's gone live, operational, is the European Hydrology Seasonal Forecast Explorer. So if we look at the image to the left, we can see an example of the drought and an example prediction of the drought over Europe this summer. So this is the forecast from June 2022 with a 1-month lead time using the E-height catchment model. You can see the red colors show a prediction that showing below normal river discharge, yellow showing near normal, and blue showing above normal. So overall, we can see in Scandinavia, we can see above normal river discharges, but as quite prevalent, the dominant signal, as indeed we have experienced, is for very, very dry conditions across much of Europe, particularly Central Europe. You can also mask out the areas that have very good skill. I think, which is a very nice feature for end users to understand what signal is in the forecast. And if you click on a river point or a catchment or a river cell, depending on which model, you can see a time series of the river discharge in 3 of the terciles, so above normal, near normal, or below normal. So this example just shows indeed that the summer was forecast to be very dry indeed in this part of Europe. Another application using the data set, and this time is from the EFAS river discharge reanalysis historical simulation. We can actually look at the past to look for a monitoring perspective, and we could look at what across the entire European river network, what was happening to the river discharge as we moved from January of this year right up until the end of August. And we can see as the animation kind of cycles through that just the severity of the dry period in the European rivers. And just the July case being a particular example of how especially extensive the dry period has been. So finally, what's in store across the operational phase of the service from 2022 to 2024? So there'll be some technical work involved to migrate the kind of pre-operational suites to the new ESUN-WF high-performance computing facility in Bologna, and to run the service in a fully supported operational environment to give users the best kind of operational reliability for the service going forward. There's work to fully integrate the CHEMS, EFAS and GLOFAS seasonal into the service. So really to have a true well-spread reflection of the multi-hydrological models that are currently available running operationally across Europe and the globe, which is very exciting. We also plan to harmonize the previous versions of the contracts and the projects, so from the Europe, Global, and CHEMS. So this will include some, the essential climate variable definitions, standardization, time resolutions, file formats, reforecast configurations to be as similar as possible, choosing common skill metrics, and as well as having a similar CDS page structure so users really can see the Europe and global services part of one overall C3S service for the water sector. There's also some service evolutions in the current phase. This will assess looking at further seasonal climate forcings beyond just CES5 and what options are possible there. So really the target in the longer term is to really be able to provide many, if not all, the available C3S, this climate models available through C3S. There's also an open question whether the current 1 degree horizontal resolution of the climate forcings is sufficient for seasonal hydrology, and that will be also assessed within this current hydrology project. There'll be improvements and optimizations to the bias correction methodologies, as well as some hydrological model improvements. So I hope that was a quick summary of the operational seasonal hydrological service. If you would like more detail on the global and the European service itself, so both Stefan Thauber for global and Peter Berg from SMHI for the European service, both have posters here, and I invite you very much to go and check them out, and if not, have a conversation with them if you get a chance. So thanks very much, and I wish you all the best.
Wishing Shaun a speedy recovery. If there's a quick question for Shaun, Chiara is probably able to answer it. Where's Chiara? Oh, there she is. And we do have a question. The question's over there. It's you, Gerard. Yeah.
I'm just curious, to be honest. So seeing Shaun's pictures, I was wondering about the extent with which you define Europe, so to say. So I didn't see, for instance, rivers in the Ukraine or the Volga river in Russia. So why did you leave it out of the European perspective?
To be honest, I'm not able to answer this question. Sorry. Yeah, to be honest, I'm not able to answer this question, so I do not know why that side was excluded by the initial definition of the domain. I'm not sure if Peter is here. Oh, maybe you know. Peter is there. Yeah, Peter from SMHI, who implemented the service.
Thank you. So the definition of the European domain depends on the water divides and how the water flows into the domain. And we're following the EFA's set up the drainage network, and this decides pretty much how much we can include in the domain. So that's why the lines were drawn as they were.